Alright, we're going to go through the CompTIA Server Plus study guide. So this is part one. This is just an overview of what the study guide is going to look like, the different parts. This is just a brief overview. So as I do another video, it's going to go more into depth into these topics that I'm briefly going over. So, server hardware basics. You have different server form factors. So you have blade servers, which basically plug into an enclosure. They're going to take the least amount of space. Tower servers are going to be like big towers, kind of like desktop computer towers. Then you have rack-mounted servers, which go into a rack, like a server cabinet. Server CPUs. Servers usually have multiple CPUs with multiple cores. CPU core basically does the same thing as having a physical CPU instead of like taking the space of having a physical CPU. CPUs use L1, L2, L3 caches. They use caches to improve the speed of processing, because otherwise, if you're having to read and write things out to RAM memory all the time, that takes time, whereas if you have a cache on the CPU, it's much faster. Your processing is much faster. Let's see, desktops and servers. So there's different kinds of processors. Desktops and servers, they use the CISC processors, complex instruction set computing, while your mobile devices like phones and tablets and things, they're going to use the reduced instruction set computing CPUs, which have less power and less heat and cooling required. Server memory, you're going to have the static RAM, which is faster, but it's also more expensive. That's what the CPUs are going to use in their cache. The dynamic RAM is going to be, that's what you think of when you think of RAM, basically RAM chips. That's going to be your main bulk of your memory, but it's not as fast as the static RAM. There's different types of RAM, so there's the double data rate, DDR3 and 4. Usually when you put RAM in, you're going to have to put it in pairs into the motherboard. You're going to have error correcting RAM and non-error correcting. So the error correcting will be for servers, because obviously you don't want an error in the RAM, because that would affect the reliability of your server. Whereas with desktops, they usually have the non-ECC RAM. They don't need like a high level of error correction and stuff. Buses and slots, so this is kind of how the computer communicates with the different devices that are plugged into it. They're going to have all these expansion cards that you put into a server. They're going to have different form factors, different sizes. So what fits in a tower, you plug like a card into a tower, it's probably not going to fit into a blade or a rack mount the same way, because it's going to be too big. The blade servers, they don't really have expansion cards per se, because they're plugged into a enclosure, which gives them all the hardware and stuff. Like usually with expansion cards, they're going to be PCI. Like if you have a server tower and you want to add a network card or a sound card or whatever. There's PCI Express, which is the fastest. Then you have PCI Extended, that's older standard, and then PCI, which was like the original. Virtualization, virtual servers are a way to really save money on the cost of physical hardware. So you have a guest, which runs on a host. The host is the actual physical computer server that it's running on, and then the virtual server is called a guest. So the hypervisor is basically the software that you use to run the virtual servers, like VMware or VirtualBox. Virtual CPUs that the virtual servers use are going to be mapped to a physical CPU core, and you have to be aware of licensing, software licensing, because some software will license to a CPU, as well as you have to be aware that you don't have too many virtual machines running at the same time, because the hypervisor can get bogged down. Your computer If you're running virtual machines on your computer, you're running virtual machines on a server hardware. Just be aware of the performance requirements. Environmental factors. So if you have a server room, a data center, you're going to have to be aware of things like temperature, humidity, airflow. You know, and they usually have complex HVAC systems in server rooms to maintain the humidity and the temperature and the airflow so as to prolong the life of the servers and the equipment in there. So blade enclosures and virtual servers will have reduced power consumption and heat compared to something like a tower server. Usually in these data centers, how things are set up is they'll have like hot and cold aisles. Basically, they'll have ways of, you know, bringing cool air up from the floor and then going through the server cabinet, and there's an exhaust on the back of the server cabinet which blows the hot air out in a way to keep all these components cool. And I guess you can also have liquid cooling. I've never seen that in any server rooms that I've been in, but I guess it exists. Fire suppression. Obviously, you don't want to have a fire in your server room. You don't want to use water because that can damage things. So one method would be to like suck the oxygen out of the room to kill a fire. But of course, you don't want to have any people in there at that time. Electrostatic Esd, that's pretty much a general rule of thumb for any working with any electronic equipment. Static electricity can damage things, so before you work on any equipment, you want to make sure that you have an equal charge to what you're touching. So if you touch like some bare metal or whatever, that can prepare you to actually touch the sensitive electronic equipment. Storage, different kinds of storage. So you have direct attached storage, which is like literally plugging in a hard drive, physically connected. Storage area network, a SAN or SAN. That's when you are storing data on a network and accessing it over the network. Then you have different kinds of drives, like solid-state drives. They're going to be faster than, you know, your traditional magnetic hard drives because they don't have any moving parts. You're going to have SCSI drives, USB, fiber channel. These are all different ways of doing storage. And then you have RAID, redundant array of independent disks or inexpensive disks. That's going to give you better performance and fault tolerance. You know, you set up multiple disks with disk striping or mirroring in a way to prevent data loss or to improve the performance. You can have a hardware RAID that's built into the firmware of the system, or you can have like software that creates RAID for you. Networking. You're going to have cables and connectors, obviously. You're going to have a TCP/IP protocol. Most devices are going to use IPv4, but they will also support IPv6, but IPv6 is not the standard yet. But it has a much bigger address space, so you're not going to run out of addresses as much which is why they kind of went to the IP version 6, because the internet is running out of IP addresses with the IP version 4. IP version 6 has some improvements as well, like quality of service, better security. Yeah, so if you use IPv6, you have to use tunneling to get it to route through the internet, because not everything is, you know, a lot of it's not completely compatible with all internet devices as IP version 4 is. So there's different layers of the network stack, which we'll go over in more detail. There's application layer, which is the user data protocol, UDP, transmission control protocol. There's different protocols that are involved in the application layer. Hypertext transfer protocol, that's like when you go to a website, HTTPS, HTTP, port 80. Simple mail transfer protocol, TCP/25, domain name service, how you look up a website like www, whatever. UDP is 53. So you need to know these port numbers and what protocol they correspond to. So servers have different operating systems, obviously. You can have physical or virtual servers. You can have a BIOS or a UEFI as a way of, it's kind of the firmware of the server when it boots up. You can have different OSs, Windows, Unix, Linux, Mac, patch management, security, or remote administration, disk partitioning, and file systems. They're all things you need to be aware of with servers. You're going to have to do all that kind of stuff. Server roles. Your servers can have certain roles, like you can have application servers that run an application that your users need to interact with. You can have web servers, which serve up a web page that your users will access. File servers, which share files and store files. Cloud storage, that's big now with storing stuff. You could have a time server, network time server that syncs all the time for your organization. You could have DNS server, a DHCP server. That's pretty standard to have that to assign IP addresses to everything. And then AD servers, Active Directory for user accounts and computers and way to manage them. So you can set up different servers to do those different roles in your organization. And maintenance is obviously something you have to do on servers. So usually you'll have SLAs, service level agreements, that customers will have with whoever is providing support. So a customer might have that with an IT department to say these are the expectations of the support that I'm going to get. Let's see, failover clustering. So that's just a way to, so that if one server goes down, it automatically goes onto another server, so you don't have any downtime. Network load balancing, that's going to be like, if you have times where there's peak activity on your network, then it'll be routed to the least busy server. And then there's ways to access your servers like SSH. I think these are more proprietary ones like integrated Dell remote access, iDRAC. I'm not familiar with intelligent platform management interface, but it's probably like the Dell remote access. Basically the way to access your server when it's completely powered down and boot it up or reboot it without actually having the operating system running. And then you're also going to have to be aware of logging, monitoring system resources, performance, all that stuff. Security, so you're going to have to be aware of hardening. Physical security would be like, locked doors and things like that, locked server cabinets. Air gapped would be if you isolated a server from the internet. It's like not physically connected to the internet. And then on the software side of things, you could disable unnecessary services to reduce your attack surface, apply patches, run anti-malware software, of course, use the principle of least privilege, which is to give the least amount of privileges and access to users that they need instead of making everybody an admin. Multi-factor authentication is going to help with security. Instead of just having a username and password, you also have something that you have, like it's kind of like when you sign up for websites and you have a code sent to your phone or whatever. That would be multi-factor. Auditing, to audit the security stance of your servers, also encryption of your data that's either on the server or in transmission between the server and something else. So network security, so that's the security standard, the 802.1.x. And you want to set up the network edge devices like gateways and stuff on your, or VPNs or whatever, on your network to forward authentication requests to a central authentication server instead of doing the authentication themselves.